Hi, I'm Swarn Prakash and I work with Intel and I wish you a very good morning to all of you. So first of all, I would like to extend a warm welcome to each one of you for joining this DPDK Summit 2018 to learn and explore opportunities. I'm pretty sure that by end of the day, you'll be having much of the informations and great learnings. So to begin with the day, we have a full packed agenda and we need your support and cooperation to execute the event successfully. Let me just quickly run you through the agenda. So we have 3 sessions before first break, and then we have 5 sessions before lunch. Then again we have, next. Then we have 3 sessions before second break, and then we'll be wrapping at around 5:15, and we have 5 sessions before that. So, yeah. And there are some interesting demo booth outside, and I would recommend you all to have a look around during the breaks. And please don't forget to keep yourself hydrated as well. So we'll start the day with an introduction and a roadmap talk by Sujata, Kanan, Jaren, and Hemant. So without any further delay, I would like to introduce Sujata, Kanan, Jaren, and Hemant. So Sujata is a network community development manager at Intel, and she has a bachelor's degree from IIT Kharagpur, and she did her master's in electrical engineering from IISc Bangalore. She moved to network software development in early 2000, and she has worked on security technologies at Cisco prior to Intel. Kanan is a principal engineer in the network platform group under data center group, and he is responsible for driving the telecommunication service providers network transformation with NFV and SDN with the end goal for successful transformation to 5G. He is a wireless domain expert, particularly in the wireless core infrastructure, driving the next generation evolution, working closely with the leading service providers. He's an avid sportsman and ardent classical and light music lover as well. Hemant is a software architect at NXP, and he is an active contributor to DPDK Summit community as well. Hemant and team recently refactored and introduced the device bus concept in DPDK to support non-PCI devices. Jaren is from KVM Networks, and he's the group manager over there. Now, may I please invite Sujata, Kanan, Jaren, and Hemant to come on stage and kick off the event. So just a small housekeeping announcement. Kindly keep your mobile phones on silent or airplane mode. And if I can request people who are sitting at back to come on front, then that will be seriously helpful. Thank you so much.
Hello and welcome to the DPDK Summit 2018. How many of you were there last year? This is our second summit. Good. Good. And thank you for braving the Bangalore traffic and being here for an early start. So to kick off the summit, we'll start by talking about what's the buzzword in the community today. 5G, right? So what is 5G? What does it mean? So here are some data. By 2020, there will be 50 billion connected devices. The capacity in the network would be 1,000 times more, and the data rate would be 50 times as well. And along with that, there will be a latency reduction of 10 times. And this is all coming from like the 50 billion connected devices, not just the devices like smartphones and iPads and things like that, machine generated.
Yeah. If you look at our Indian scenario, right, of late, like we have a huge revolution in terms of data traffic explosion in the wireless world, right? So if you look at the current projection, right, we started with 1.3 exabyte per month. all the way 11 times it will go up till 2023. These are all using the current LTE network and the LTE advanced network. Now think about what will happen if 5G deployment starts happening somewhere like expected around like 2020, 2022, that kind of region. Think about the data traffic, how much growth, and what will happen to all the network elements happening starting from your base station all the way to the data center where the applications and other things are hosted, right? So just to give you an idea that each mobile phone, currently the smartphone LTE is capable of producing 1.3 gigabyte uh, traffic, and it is also expected to grow at 11 times. So the devices space is also going to change based on the application, nature of the applications that we are going to see.
So 5G, in addition to being a transformative technology, like the physical layer and the software layer and how we think of 5G as a network, it is the real value is coming in how it will change how we interact with the system, right? So there are different use cases in healthcare, in automated driving, in smart cities, the way agriculture is done, the way we manufacture things, the way we ship things, and of course in the entertainment, right, how we play games, mobile offices, and things like that. So each of these use cases have different demands on the network, and the same network has to meet these demands. So this is why there are different buckets that we have put the 5G use cases in.
So basically what we call famously is three tenets in which the 5G, because 5G is the amalgamation of everything, right? The basic three tenets is first, okay, I want to have more data rates. That's enhanced mobile broadband categories where you are going to experience 4K videos and whatnot, right? IR, VR experience, now it makes more realistic. So you need to have a ultra low latency kind of experience where you are doing a medical imaging or any real-time feedback that you need to provide, right? Those kind of categories of applications demands different set of attributes from your network. And of course, with the advent of IoT, you are not the human is carrying the device is going to connect to the network. It's all the massive machines is going to connect to the network and talk to each other, and like they live independent life. So it's going to be a massive explosion of devices that are coming onto the network. Right, so what we do for this, the network cannot be a static network. As we know that we can't like, each attributes are 180-degree apart. So if you want to meet those kind of things, you can't apply the current static network that's prevalent in this current LTE up until the LTE network, right? So you need to morph the network adaptive to the workload or the application experience that the end user or a device is going to experience, right? So the concept of network slicing has been kind of FOMO technology that's been proposed in 5G, where the networks can be sliced and each applications can have its own part of your network slice which can address your needs. If it is ultra low latency applications, the complete network moves all the way from data center close to your edge, right? Your slice of your data plane, completely core data plane moves right across there. Your MEC kind of application gets hosted there. So what you are experiencing as an end user will be to meet that ultra low latency stuff. Similarly, there are many categories. This network slicing will help.
Yeah. So like we were talking about these use cases, right? So when we're talking about use cases like from IoT, they are not very latency sensitive in the sense, but then they have massive data. For example, in agriculture, if you're talking about getting the sensors which can talk about what is the moisture The data is important because action needs to be taken on that, but that's not latency sensitive. But if you're doing something like you're operating a patient and you need access to some database like virtually, don't know if it will happen, but that's one of the use case, right? So there you don't want any latency there. Definitely, if I am driving in an automated car, I don't want my car to crash on something else because it didn't get the data in time of an accident ahead or something like that. So that's what this is basically translating what you saw in the previous slide onto the network, how the network can be structured today at a high level. Right? So your devices are connected to the base station, connecting to the backhaul, going to the EDC and the eNode B. And each of these elements have to get transformed from the vertically integrated boxes to flexible, agile, software-based solutions.
Okay, now you can ask me what will be the feature of the network, right? We are all living in the business world, right? So we don't want to throw anything away. So whatever you can still see, we will use voice call originating out of the GSM, which is more than a couple of decades ago, right? We still use those technologies. So the technologies and the equipments what's deployed is not going to run away. So what you are seeing on the left-hand side is the various access technologies that's going to be there and continue to be there along with your 5G. So what's happening is there will be devices with various access spectrum that will be bombarding into your network. Once your access technology is kind of making all the traffic as IP based, then you are entering into the packet world. Once you have the packet world, then right-hand side infrastructure, which is the NFV based, which allows you to achieve all the things that we are talking about. Now you can ask how DPDK is going to help in all these things. You must have guessed it, right, when I said we are going to talk about handling huge number of traffic. Data traffic is not, we are not talking about in Mbps, not even Gbps. We are going to talk about terabits, right? So now you need some kind of technology in your network systems to handle that terabits kind of packet processing. And what better than DPDK can solve these problems, right? And also we are talking about low latency and predictable things. All of these factors is kind of enabled by the underlying DPDK thing.
Yeah, so this is basically drilling down to the nitty-gritties of it, right? So this is basically a typical packet processing pipeline. So you get your packet in, you parse the packet, and then you classify where that packet belongs. So we're talking about network slicing, right? So the foundation of network slicing is classifying the packet, right? Classifying the flow, where that packet comes from. Whether it is coming from a flow which is belonging to, say, IoT use case, or it is on a video streaming use case. Right? So each packet stream has a quality of service parameter which is dedicated or which is guaranteed for that stream. So each packet has to be qualified belonging to one stream or the other, right? So once you qualify the packet where it belongs, then you need to maintain some statistics on the packet, right? So when did the packet arrive? What was the inter-arrival time? Whether it is complying with the bandwidth guaranteed for that particular flow. You know, those needs to be maintained. And then it needs, the packet processing needs to be sent to a particular core. When we're talking about DPDK here, right, we have multiple cores here. And then the worker thread takes up and takes up the processing and then takes decisions whether the packet needs to be sent or needs to be dropped based on the parameters, whether that packet is compliant. If the packet is over the bandwidth, the committed bandwidth for that particular flow, it will be dropped, otherwise it will be, forwarded. And then it goes out of the pipeline.
And if you are looking at it, why we are talking about it, if you look at the DPDK, what it does is it's trying to standardize the API, right, for each of these services. For example, you can do perfect scheduling at 10 gig speed in the software domain, right? But if you want to do it in the same thing at the 100 gig interface, if you are doing it in software and by the time the packet shows up in the interface, all the your QoS treatment that you have done, scheduling treatment has done, it's get lost. So most of the time you will choose that the scheduling needs to be done in the hardware or the closer to the interface where it is, right? But you don't want to change your applications where you have, what all application needs is the treatment, right? I need the services from my underlying layer. All I need to know is whether my traffics are treated properly, right? So I don't want to change my application interface. So the DPDK allows you to run the QoS, as an example, the scheduler in the uh, basically on the compute itself, or you can offload it to your NIC via the PMD standard offloading capabilities.
Yeah. So here is one of the applications for the DPK, OpenFlow or OV switch. How many of you are familiar with OpenFlow OV switch here? A show of hands. Quite a few, but not the whole lot. So OpenFlow is one of the protocols which is now kind of standard in the industry for packet processing in the software-defined networking world. So what OpenFlow does is it abstracts the packet processing into these actions. So you either forward the, you map the fields of the packet, classify the packet, take an action, and collect some statuses. The actions could be forward the packet link, activate the packet to a controller, send the packet for normal talking pipeline or modify fields. On the bottom right, you see a table, a typical table which would be, a OpenFlow table. So here, the actions which I have put here are, they're going to a different table. So each table is implementing a network slice here.
So why are we talking about this? So as we said, right, SDN is one of the important technologies that we will be considering to enable this, right? So the OpenFlow switches, the hardware ASIC-based, TCAM-based switches are prevalent and they are able to do things at blind rate, right? That's been their bread and butter. Now, in the virtual world, right, what we are talking about in the virtual world, you need to have multiple tenants running on your compute server. You need the capabilities just like my SDN switch, some kind of a virtual switch running on my compute platform. I don't want to change anything the way I have been programming so far in the physical world. I want the similar kind of capabilities in the virtual world as well, right? That's where DPDK is kind of bringing you that kind of performance with this in the virtual world, the virtual switching also enabling the same construct of an OpenFlow or an SDN switching thing.
Yeah. So since we've been talking about DPDK, let's just give a perspective of how the DPDK community has grown over the years. So this is one of the KPIs through which we track how the community is doing. So number of contributors and commits to DPDK. So as you see in the graph, it's been growing over the years. Started
So what it tells is, you can clearly make out that India has largest developer community, and we do have, even though like you don't see not many open sourcing or upstreaming effort is happening compared to other geos, but DPDK changed that thing. So that's the reason why we are having a focus summit in India. So I welcome all the participants to start contributing more. We know that they are already contributing, but we just want to request you to contribute more.
Yes, when we started this in 2017, there was a question whether there is a need for a DPDK summit in India. But you guys here are proof that there is a need. So we want to thank our event sponsors, Intel and F5 today. And Mansoor already showed the agenda. So we have a packed agenda today. With this, we'll give the floor to Jaren and Jacob to introduce about the tech board.
Welcome.
Welcome.
Good morning. So, as Kanan mentioned about DPDK is now growing as a very good technical community. So, we thought let's also talk about how DPDK technical governance takes place, and we want you guys to contribute. So, we want to give you an overview how DPDK governs the project technically. We are not talking about managerial aspects here. So when the DPDK project got started, it was a single vendor, and things were very easy to maintain, like you can do a consensus and everybody can just come together from a single company and people were contributing to DPDK. But later DPDK started growing. More vendors, different architecture, they wanted to put their code into DPDK. And there are quite a few instances where we were not able to reach consensus, how to do the thing rightly. So a DPDK technical board was formed across vendors, across architecture, nominating the people who are the most trusted contributors, and then the DPDK technical board was formalized and it was put into the DPDK charter. So what is this DPDK technical board? Now DPDK technical board has 9 members from different companies, largely from Intel, Mellanox, KVM, NXP, Microsoft, 6Wind. One of the DPDK technical board member on a rotation basis, he goes as a representative to DPDK governance as well. Right now, Jaren is the nominated member for the governance board for this quarter. Typically, on a DPDK technical board, we have a IRC-based open meeting every 2 weeks. There is a fixed time. We announce the DPDK meeting every 2 weeks to the DPDK mailing list as well. Anybody can come and join on IRC. Typically, it includes approving new functionalities, approving new subtrees, creating, giving opinion on the new projects, or providing technical input if somebody is looking for a technical input for a particular contribution. And we can also talk about there on a voting basis that technical decision if we are not able to reach any consensus for a particular topic on the mailing list. Because we don't want the fighting to happen on the mailing list. We generally take those topics off list and we can talk about them in that technical board meeting, and it's a public meeting so anybody come and can see. One of the major things we did with the DPDK, because as the DPDK is growing, more and more people are companies, customers are started using DPDK. So we want to make sure about that we are not violating any intellectual property and we are aligned with the intellectual properties. So we put a proper format how the DPDK code should be licensed. So right now, DPDK as a user space, the code is licensed as a BSD3. There are some exceptions, like the kernel code is GPL v2 licensed, and the files which are common between kernel and user space, they are naturally dual licensed, GPL v2 and BSD. And in order to ease out, like because we have to also see the size of the code, and we see every file having a big license header for BSD, we decided let's move out. So we introduced the SPDX concept, which is also a Linux Foundation project, and we started putting these small tags, SPDX license identifier, and a small copyright to each file, and we have, from 1802 onwards, we have started removing all the copyright information, the big license tags from the source file, and we have moved to the SPDX license tags, and we are targeting in next 1 or 2 release, we will make whole DPDK SPDX compliant. Having said that, when you are putting your code to a BSD3 license, many times there are contributions which come from a different license. For example, if somebody is contributing a code from Apache license, or somebody is contributing a code from BSD4 or BSD2 license, how to deal with these things? So first thing is, on all such cases, the technical board comes into the play. Technical board sees if there is a merit to that contribution, if that contribution is important for the community, then we go and talk to the governance board whether we should add, if the governance board is okay to accept that as a legal proper license for the DPDK or not. There is one help which we are looking for right now. All this license check in the each patch is right now manual, and we are looking for a automation. So right now in our patch work, some people are working, but if any volunteer, more than welcome to join us and help us in automating the patch check with respect to the license. DPDK has many repositories. The main repository is the dpdk.git, but there is another stable tree. I will talk about the stable releases later, but there are repository which maintains the stable trees. Then there are tools like DPDK website is maintained by DPDK web. Then there are applications like PacketGen or Soft Switch panel. They are also maintained. And as a standard open source tree, we have our staging trees like NetNext, NetCrypto, and different kind of tree. And we also have a concept of draft tree, because whenever some big proposal comes and we don't want it to disturb the main tree, we generally give them a draft tree so that community can work on the draft tree, and once the proposal is finalized, we can move them to a next tree or to a proper DPDK tree. DPDK generally makes 4 releases every year. That means a release every quarter. Like we do a release in February, May, August, and November. Out of these 4, only one release is LTS. So right now 16.11 is a long-term stable release, 17.11 is also an LTS release. Because it takes some effort to maintain a LTS release, so that's why we are only doing one release a year as a LTS release. Typically, there are maintainers. Generally, the role of maintainer is to answer question and make sure that patches related to that particular modules are reviewed. There are main committers. The committer's responsibility is, the main responsibility is to make sure that patches are reviewed on time. And we are looking for reviewer, because right now at each open source community, we also have a problem that patches are not getting reviewed on time for many of the things. So please come and review our code. DPDK has quite a few tools with respect to the maintenance. Like we use the patchwork for reviewing and maintaining the patches. There is a CI integration which automatically checks for the compilation as well as the coverty and other issues. Then we are right now setting up a performance lab. I will talk about that in a different slide. We have recently set up a Bugzilla for reporting bugs on the DPDK, and DPDK roadmaps are right now being published on the DPDK website. So we felt a need for a DPDK open lab, and the main reason was that whenever somebody is contributing a patch, we have to make sure that that patch is not doing a regression on anybody's platform, because there are now multiple platforms. Intel is supporting, many of the ARM vendors are supporting DPDK, PowerPC vendors are supporting, and then there are Linux architecture, there is a BSD architecture, and Windows architecture is also coming up. So we have to make sure that your patch is not breaking and not doing any regression on any of these architecture. So we have set up a lab, and right now the lab is being set up in the University of North Hampshire. We have already signed the contract. Right now, Atomic Rules, Intel, Mellanox, and NXP are shipping their boards there. Intel and Mellanox has already shipped the board. Other two are in the process of shipping the board.
Thanks. Hello. Yeah, thanks, Hemant. So this is not the final list, but we picked up from the mailing list what are the few items that can come up on the next release. And since it's an open source community, so anyone can contribute. So this list is not final, but trying to touch upon the items what we saw on the mailing list. Yeah. Yeah, so this one is the existing release. I'm going to talk about the roadmap next. So this one we covered about, we introduced the SPDX license header as Hemant mentioned. And DPDK is now currently abstracting all the hardwares. So like we have started with Ethernet device abstraction, then they had a crypto device, followed by we had a scheduler device hardware abstraction. It's called event dev. Then we recently introduced something called wireless baseband device. This is abstracting hardware devices that have with wireless baseband capabilities. So this way, currently we have a software driver with that. So and future we'll be enabling, or anyone can add the hardware support to that thing. So in that way, so applications will not get changed. The same API will be used for both software and hardware in transparent way. And we introduced the raw device class, where there are some type of devices where it does not exhibit a common attributes. So it's like some of the LTE devices or timer devices or anything that category. So NXP introduced a subsystem called raw device, where it's just set of functions pointers for enqueuing, dequeuing any type of void pointers. So we can plug in any kind of devices to that thing, and we can have a unified API to get access to the application. So then after that, we introduced ETH dev probe notifications and ownership, and Hyper-V platform driver. So this is a recent improvement where earlier the DPDK was very much biased with the PCA device itself. Then we introduced a bus driver where any type of buses can be added to the DPDK. So the first one was PCA. We moved to that. Then the SOC specific buses were moved into that thing now. As another bus, we added a Hyper-V also. Then another feature was AVF Ethernet driver supports. This was a good feature where the problem statement was something like, in a virtualized domain, so we may really don't know what kind of Ethernet hardware may be running underneath, right? So what we did is like typically if you see in different hardwares, like we'll have a base, the hardware structure for the ring descriptor for the hardware devices typically will be same. So what we did is we created a minimal driver which has a bare minimum functionality like transmitting and receiving the packet, but the same driver can run on any, meaning say, different type of devices from the same vendor. So that way you don't need to worry about in a virtualized domain, like what is the real underneath device is sitting in there. Then we added an IPsec inline offload support for DPA. So basically we created a framework called RT security, which is going to talk by Hemant next slide. So which is nothing but if you see latest hardware capabilities, we have there are hardwares where we can do the complete IPsec inline offload support in hardware. So this framework create that abstraction, and we plugged in one offload as a proof of concept. Then, yeah, so then event dev driver, and so we'll move to the roadmap now. Yeah, so these are not the final list, but whatever items we got it from the mailing list, we added here. So the one thing is like we are going to have a Windows support. So Linux, the DPDK has EAL abstraction where you can plug in different execution environments. So it can have a bare metal system or Linux or Windows. Currently, Linux is the free-based. Linux and free-based is the only execution environment is supported. So this is going to add the Windows support. And Hyper-V support, full-fledged support will be added through bus subsystem. And there is compression API support. So the latest hardware is we can have a compression hardware where you don't need to take the CPU cycles to do the compression. So we are creating a new compression API framework, which is going to talk by other people. So it's going to add that, and we are going to have a standard software driver and hardware driver for that thing, so that applications can use the same API. Then the new security offload like MACsec and other things. So IPsec is added now, so we new support like MACsec or asynchronous support and things like that. And STP support is a new thing is coming up from the Linux world, where there is a means where we can do the zero copy to user space through XTP driver. So this is a standard PMD driver which will run on top of XTP to get the packets to user space, so that we can leverage the Linux subsystem for getting the packets to user space without memcopy. And yeah, we have a new build system which is it's very fast now. So currently the make system is not really good because it has a lot of dependencies and things like that. So which is fixed to with Ninja build system. So and it follows standard package config model where you don't need to have a specific configuration things and like that. So as a user space library, this is going to be enhanced with new build system and memory management support to add the hot plugging. And yeah, the Virtio crypto driver is going to add. So Virtio net driver is currently there, so that in guest you can get the packet without any hardware acceleration scheme. So the similar stuff is going to happen on the crypto side, where they will standardize the descriptors for a crypto work, so that in guest with the hardware accelerated backend on the host, we can get the crypto work. And yeah, so we had an event dev subsystem now which can inject the Ethernet packets now. So this is going to be extended to add crypto support, where once you submit a work to crypto, and once crypto work is getting completed, it can notify back to event dev. So that adapter plugging logic will be added to DPDK. Again, so with that scheme, both software and hardware scheme will work transparently. So application does not need to change. So crypto adapter is going to add. In addition to that, there is a timer adapter for event dev, where the timer expiry is instead of callback, it will be get added to an event dev as an event. So an application can get an event and see that the timer got expired. So, and we are going to add more event dev examples. So currently we have multiple examples like pipeline and other things. So we going to extend the L3 forward and another standard applications to put in more event dev framework for scheduling support. And raw devices support is already available, so we're going to add a new devices and command line library more. So that's it. So any questions? Yeah.
So there are mics on both sides.
Oh, okay, I got it. So when you say Windows support, is it like Open vSwitch support? Are we going to have a DPDK based Hyper-V virtual switch also in
Yes.
Windows Server?
Yeah, so Windows support, what we meant is like we have an execution environment that runs on Linux and FreeBSD now, right? So now DPDK can run on standard Windows, where all the standard applications can run on Windows itself.
Okay. So my question was OVS DPDK has come in, right? So which actually adapts Open Virtual Switch in DPDK framework.
Right.
So my question was more inclined towards whether the Windows Hyper-V virtual switch, will that also come with DPDK support, or we can compile it with DPDK in Windows machine itself?
So right now, the first step towards it is there are contribution from Microsoft and Intel, and there is already a draft tree created in the DPDK community, where as a first step, the DPDK itself is getting plugged into with the Windows support into the DPDK community. And right now we are not aware of the patches with respect to the OVS, but DPDK community as a standard open source community, it's open for any contributions and any suggestions.
And once Windows environment support is added, then they can use the same DPDK APIs, right, on the OVS Windows platform ourselves, right?
It's
so
an open source community, so anybody can come and contribute, right? We have not seen the contribution towards OVS yet.
One more question regarding.
Yeah, Kanan, you want to?
So as Hemant said, we are adding the basic DPDK enablement in Windows. Yes, of course, the follow-on will be the visual switch. Hyper-V switching also will be targeted for the DPDK enablement as well.
One more question. When we say Hyper-V support, is it like now in Hyper-V the VM bus architecture will be integrated, or will it be still a virtual device architecture which is current?
Yeah, it's marked as a bus, so it's just a generic bus stuff support we added as a bus framework, and so I think in this support, I think Mellanox is going to work on that. Microsoft and Mellanox combined, they're going to working on. I don't know what exact features are going to add it. So the base bus support will be added now.
Thank you.
We'll take one more question.
I have a question on the NIC support basically. So I was recently working on DPDK plus OVS, right? So I had realized that the Realtek NIC is not supported as of now, right? So I just wanted to know if we have any plan to make it NIC independent.
See, DPDK, if you see DPDK is actually a set of drivers. Yeah. It's just a small abstraction layer over the hardware drivers. So that NIC, I don't know who it belongs to, but that NIC, they need to provide a driver to the DPDK, and they can seamlessly plug the driver to the DPDK, because DPDK is all about talking to the hardware in a most efficient manner. So DPDK provide a small common API over the hardware drivers. So we need to have that hardware driver submitted to the DPDK, and then only it can work, because as an open source community, we don't write drivers for others' hardware. The hardware vendor has to submit their driver to the DPDK.
So you want to say that the Realtek guys has to put the hardware drivers, and that will be included in DPDK?
Yeah, if they submit, we will include it. There is no reason we will not include it.
Okay, thank you.
Another thing to add is, like, if you want to have a generic driver, you can use a Virti or any other platform neutral drivers.
AF XDP driver, AF packet driver you can use, but you will not get the best performance in that case.
One more question I have, sorry. So when we are talking about DPDK, we have one more option that is called as SRIOV, right? So SRIOV seems more appealing than DPDK, because the thing is that in the case of DPDK, we have to reserve the CPUs and the memory, but in the case of SRIOV, that is not required at all. So how you want to see that in future?
No, it's both same thing. It's a different technology, right? So you are talking with respect to the virtualization context, right? So the PMDs can run on top of the direct SRIV. So I don't need any other CPUs to get the packet. So if with an SRIV, so DPDK and SRIV married together. So you can have a PMD which runs on top of direct SRIV.
Okay, thanks.
Okay, thank you.
Thank you.
You can get in touch with the speakers offline.
Excuse me, I had one more question.
We are running out of time, so if you can please get in touch with the speaker offline, that will be seriously helpful for us as well.
Okay.
You can get in touch with the speakers during the break time as well. Thank you so much, Sujata, Hemant, Zerin, and Kanan for the kickoff. Now our second talk is by Mr. Xiong Wang on ideas for adding FPGA accelerators to DPDK. Xiong Wang is a software engineer at Intel and is focused on virtualization and performance optimization. And so I would like to request all the speakers to please come in front, and I would special request to Mr. Akhil Goyal, please come in front, and you can tweet about this summit at #DPDK Summit. So I would like to request Mr. Xiong Wang to please come on stage and enlighten us. Thank you so much.
And then we'll talk about the partial reconfiguration and what is that. We all know that FPGA is reprogrammable, but when just like any generic computer in the early days, it's programmable, but then you can just input the program in the initialization phase, and it runs, and then it returns. That's as much as I can tell in the early days. But it's just like FPGA. So when you have more and more resources, you need better management system to manage all those resources. Not you can give the resource not to one user, but you can give them to multiple applications and run them at the same time and without interrupt each other. So that's the way it has to be for FPGA in the future. And also in the present, I guess it's already happening. So just take several examples, right? Why partial reconfiguration is a must in data center business. First, let's take a look. If we have FPGA acceleration for our networking, right? Like, for instance, switch. And why we use FPGA is because it can be reprogrammable. And just like any switch, virtual switch, we need to update them. And we need to add new features. So in that case, we don't want to shut down the whole system just to update our switch, right? And in that case, we need hard upgrade, which means we can just power on the FPGA and re-download the image, and maybe within several microseconds, the whole system will be back online again. So that's hard upgrade. And another scenario would be like infrastructure as a service. Like we can, when FPGA entering the data center, we can use it for infrastructure to be virtualized to provide service for our customers. Like, for instance, our customer said, I want 2 FPGA a month, and then I'll provide you the bitstream, and you can download them for me, and I'll just use them for 2 months. In that case, we also need partial reconfiguration. That's the statement. And then the question, let's go back to the question is, how DPDK fully support FPGA? I guess just like we have talked about is, first, we need DPDK to take care of the reprogrammable part of FPGA. And another part is we need DPDK to, just like any other device, the DPDK device model currently support, we need DPDK to take care of the actual device driver, the actual device personality of that FPGA, or it can be many devices in one FPGA, right? So now let's take a look at from hardware point of view, what we should do to support this. Just like, let's go back. I'll use a computer again to demonstrate this. So each device, you can provide many services. It has many features, but some of them are, not likely to be changed frequently, but a lot of them, like the applications, it can change over time. It can be changed very frequently. So for any system, just for like for FPGA, it's also true that if we want to do partial reconfiguration, if we want to do like hard upgrade, anything like that, we need to separate those services. Like for those that like system attributes, we should make them stable and fixed just when the server boot up. So that's why, I mean, in Intel's term, there's blue, we can see the blue part and green part. So the blue part is, it's fixed when the server initialized, just like the BIOS. And the green part is actually user applications.